This is Module 12, first video. So far in the course, we have talked about hypothesis testing to try to understand the true value of pi. When we did that, we made a hypothesis about the value of pi. We created a distribution of sample statistics, and that was a bell curve centered around pi. It showed us what the sample statistic p-hats would be expected to look like if it was true that the true population parameter was pi. You would then go out and do an actual sample. You would locate your observed sample p-hat, possibly somewhere out here in the tail. You'd get a p-value and use that p-value to make a decision about whether or not your null hypothesis seemed plausible, or did you have sufficient evidence against the null hypothesis to reject it. Similarly, we also have talked about hypothesis testing for mu. When we did hypothesis testing to try to understand the true value of population parameter mu, we would hypothesize the true value of mu, and then we would use a simulator to tell us, all right, here is what your sample statistic x bars should look like, are expected to look like. If it's true that the true population parameter is equal to mu, then you would go out in the world, you would do a sample, you would get a sample statistic x bar, and you would locate where your x bar falls on that sample distribution. And you'd find a p-value and you'd say, here is the likelihood of getting a sample statistic x bar like mine or more extreme. And then you would make a decision about your null hypothesis. Does your null hypothesis seem plausible, or does your do you have a lot of evidence against that null hypothesis so that you would reject it? We are now going to do exactly the same procedure, but we are now going to do it for trying to understand if there is correlation between an explanatory variable and a response variable. But it really is the same idea. We are going to make a hypothesis test about the population correlation coefficient rho. We are going to make a hypothesis. And our hypothesis, we're going to talk about that in a moment. Our hypothesis about rho will always be that there is no correlation in the population. We'll talk about that in more detail in a minute. And then we're going to create a distribution of sample statistics. Our distribution of sample statistics will be the distribution of sample correlation coefficients R. This distribution will show us what we expect sample correlation coefficients to look like if our null hypothesis is true. Then we go out in the world, we collect a sample, we locate our sample correlation coefficient on our distribution of sample statistics. We find a p-value. And we say, does our p-value tell us that we think the null hypothesis is plausible, or does our p-value give us a lot of evidence against the null hypothesis? So it's really the same procedure, same thing. We're just doing it in relation to correlation coefficients.